Okay, this lesson is on some difference and double angle identities, and in this video we will be looking at only a part of the lesson, and then we'll finish the other part in class. So if we look at these identities here, there are two for sine, showing the sum of angle A and B, or the difference, ditto for cosine, and then down here for tangent. It's a little bit more involved calculation for tangent than sine and cosine. All of these identities are on your formula sheet, so you'll need to have that handy to do the work today. And let's just look at a few of them. So we're asked to simplify using a sum or difference identity. So in the first one, we've got a difference, subtraction, and a cosine. And so that identity, if you're looking at your formula sheet, is that the cosine of A minus B is equal to the cosine of A times the cosine of B plus sine A sine B. And so in this particular example, A is 180 degrees and B is the Greek letter, beta, which is like a capital B with a little bit of a tail. So the cosine of 180 degrees minus beta is cos 180 cos beta plus sine 180 sine beta. And if we think about 180 degrees, we draw our unit circle. 180 degrees is here, and the coordinates of that point over there, x is -1, which is our cosine, y is 0, which is our sine, and then we just fill those in for cosine 180 and sine 180. And so I would get -1 cosine beta plus 0 sine beta. So this portion is going to disappear when I times it by 0, and I would just get that the cosine of 180 minus this angle is equal to the negative cosine of that angle beta. So if you look over to this side, the sine of pi over 2 minus x, I'd like you to identify the identity that we're going to use in this case and try and solve it. So this would be a good point to pause the video and try that one out. Okay, hopefully what you saw here with the difference and of sine is that this is sine A minus B is equal to sine A cos B minus cos A sine B. And in this case, A is pi over 2, and x is our B. So the sine of pi over 2 cosine x minus cosine pi over 2 sine x. Let's write that a little bit neater, or not. Sine of pi over 2, so again, that's 90 degrees right here. We want to think about our unit circle. The coordinates of this point are 0, 1. And so the x value of 0 is our cosine, so that's going to go here. And the 1 is our value for sine. So 1 cosine x minus 0 sine x. Again, this is going to disappear just like it did over here in that example. And the sine of pi over 2 minus an angle x is equal to the cosine of that angle x. All right. In the next example, we are simplifying something and then evaluating it. We're determining the value of this. So in this case, I've got the sine of 70 cosine 20 plus cosine 70 sine 20. And you can see that this is really the sine of A, where A is that 70, cosine B plus cosine of A, again A being the 70, and sine B. And this is really just our identity for sine A plus B. So in this case, we're kind of working the other way. And A is 70 and B is 20. So this is really just the sine of 70 plus 20 degrees, which is the sine of 90 degrees. And if we think again about the coordinate plane here, sine of 90, up here at 0, 1, this is the sine. So this is really just equal to 1. Over here in part B, it's a little bit uglier. We've got a tangent calculation now, and we can see that if we look at the formula sheet, because this is a subtraction up here and an addition down here, this is our tan A minus B identity, where you can see we have that's equal to the tan of A minus the tan of B over 1 plus tan A tan B. And you can see up here that A is 15 pi over 8. That's going to be our A. And 3 pi over 8 is B. So again, I'm working kind of in reverse. I have this, and I'm going to make it that. So you can see the ways that the identity can work in forward and reverse. So the tan of A minus B, except in this case A is 15 pi over 8, and B was 3 pi over 8. If I subtract those, I'm going to get tan of 12 pi over 8. And if I reduce this fraction in here, that's the same as tan of 3 pi over 2. So again, I want to look at my unit circle and think about where 3 pi over 2 is. Well, that's here. And the coordinates of that point are 0, -1. And what we want to remember as well, that's also on our formula sheet, is that the tan of an angle is the sine of that angle divided by the cosine of the angle. And we've seen that lots, so hopefully that's something that you remember. So the tan of 3 pi over 2 is going to be its sine, which is the y value, divided by the cosine. So in this case, I'm going to get -1 divided by 0, which is undefined. So in this case, we have an undefined, we don't have an answer really for this one. All right. Coming up next, we're looking at determining the value, the exact value. So that means with roots and things, we're not rounding a number we got in our calculator, using a sum or difference. And so here we have to be a little bit smart about fractions and know that, for example, 1/12, this pi over 12, 1/12 I can get by subtracting, say, something like 3/12 minus 2/12. And 3/12, well, if I reduce the numerator and the denominator by taking out a 3, I get 1/4. And I'm subtracting over here, if I divide those both by 2, 1/6. So to to represent the sine of pi over 12, I'm going to call that the same as the sine of pi over 4 minus pi over 6. And the reason why I'm picking 4 and 6 is because these are values that I know from the unit circle. And then at this point, I'm going to apply the, 12. I'm going to apply the difference identity for this sine, and that's going to look like this. Sine pi over 4 cosine pi over 6 minus cosine pi over 4 sine pi over 6. So this comes off of our formula sheet, again, where this is A and this is B, and it's the difference for sine. And now I'm going to evaluate each of these and sub them in and figure out what sine pi over 12 is, again, as an exact value. So from my unit circle, I know that pi over 6 is my 30-degree angle out here, and so my cosine is root 3 over 2, sine is a half, and pi over 4 is the 45-degree angle, and that one's easy, it's just root 2 over 2 for both of them. And now I'm just going to substitute these values back into my equation. So the sine of pi over 4 is going to be root 2 on 2 times the cosine of pi over 6, well that's root 3 on 2. So I sub that in, and I'm taking away cosine of pi over 4, which is also root 2 on 2, and the sine of pi over 6 is 1/2, the y value for that 30-degree angle. So in my next step, I've got the sine of pi over 12, is here root 6. Remember, I multiply the 2 and the 3 because they're both under the radical, and 2 times 2 is 4, that's my denominator, minus root 2 over 4, and I'm just going to write that together as root 6 take away root 2 over 4. And that is the exact value of sine pi over 12. And if we turn our attention to this one, tan of 105, we're going to be applying tangent identity, sum or difference, your choice. So think about what two angles you could add or subtract to get 105. So maybe this would be a good point to pause and try that one out. Okay, the angles that I've chosen in this case are 45 and 60. So I did the tan of 45 degrees plus 60 degrees. And now I'm going to use the tangent sum identity on my sheet. So that is that the tan of 105 is going to be equal to, remember this, 45 is A in my case, and 60 is B. So I'm going to have the tan of 45 plus the tan of 60 over 1 minus tan 45 tan 60. All right, myself some more room here. I might just get rid of this. There we are. So the tan of 105 is equal to, and now for 45 and 60, I might just draw myself another picture of the unit circle. Here's 45 degrees, cosine, sine, 60, now I'm up here, so I'm farther up than I am over to the right, so that means the x value is smaller than the y value. And those are going to be important for me figuring out the tangent over here. So first off, I've got the tan of 45, which means I divide my sine by the cosine. And these are the same thing. So that's going to turn out to be 1. In other words, root 2 over 2 divided by root 2 over 2 is 1. Plus, and then down here, I'm just going to fill out that 1 because this is the same number down there. And now I have to figure out the tan of 60. And so up here, the tan of 60 is going to be this value, the sine, root 3 over 2, divided by its cosine, which is 1/2. And so we remember from fractions that I times by the reciprocal, these 2's cancel, and so it's just equal to root 3. So I fill that in there and there. And so the value for the tan of 105 is going to be equal to, degrees, is going to be equal to 1 plus root 3, that's my numerator, divided by 1 minus root 3, that's my denominator. If I wanted, I could rationalize that, but let's just leave it at that for today. Okay, for our last example, our last two examples, we're looking at secant of 5 pi over 12 and evaluating the sine of a plus a. So if we start with this one, this is a sum double angle, and we know that the rule is sine A, cosine A. In this case, B is also A, it's just repeated, plus cosine A sine A. And if I just rewrite this, you can see that I would have sine A, cosine A again. So I have 2 sine A, cosine A. All right, and if we turn our attention to this one. All right, if we turn our attention to this one, secant 5 pi over 12, what I'm going to find first is the cosine of 5 pi on 12. And then when I get my answer, I'm going to take the reciprocal of it to then get back to the secant. So 5/12, I want to think about how to obtain 5/12 as my answer. And so I'm thinking 8/12 minus 3/12. And 8/12 is 2/3. So this is like 2 pi over 3 minus 3/12 is, of course, a quarter, pi over 4. So the way I'm going to end up with the cosine of 5 pi over 12 is by doing the cosine of 2 pi over 3, which is the same as 8 on 12, minus pi on 4. And if I turn my attention to the formula sheet for the identity for cosine and difference, then I get something that looks like this. Cosine A, which is 2 pi over 3, cosine B, which is pi on 4, plus sine A, sine B, which is pi on 4. And now I think about where these are on the unit circle. So pi over 4 is here. That's my 45-degree angle, and I have root 2 on 2, root 2 on 2. And 2 pi over 3, that's over here. That's like 4/6, right? So I count out 1, 1/6, 2/6, 3/6 is my 90-degree out, and I'm over here for 4/6, or 2 pi over 3. And the coordinates for this guy are -1/2 and root 3 over 2. So I'm going to sub those in over here. So the cosine of 2 pi over 3, this here is the x value, so that's -1/2, times cosine of pi over 4, that's root 2 on 2, plus sine of 2 pi over 3, that's root 3 on 2, that's this one, the sine, and the sine of our other guy, root 2 on 2 as well. And now I'm just going to do the multiplication. So here I get negative root 2 on 4 plus root 6 on 4. And if I combine those, I'm going to have root 6 minus root 2. I've just swapped order all over 4. And that's the cosine of 5 pi on 12. So the secant, therefore, of 5 pi on 12 would just be the reciprocal 4 on root 6 minus root 2.